Hey everyone, so in this video we're going to look at what an algebraic expression is, right? So we'll show you the the basics of an algebraic expression, what we mean by the terms, what we mean by the coefficients and so on. So look at this, what you see in front of you here, 4x plus 3. This is an algebraic expression. So just observe this for a second and can you guess, or can you see what you observe from this. So you see there's a variable x, right? Generally mathematically when you see something like this, x is a variable. So an algebraic expression clearly can have a variable. You see numbers, so 4 and 3, which means constants. And then you see a mathematical expression plus an operation, right? So that's an operation. So that means an algebraic expression can have constants, variables, and mathematical operations. So the variable is x, the constants are 4 and 3, and the mathematical operations are plus and into. Now when you look at it like this, 4x, a lot of the time it's easy to forget the into, but actually 4x is 4 times x, so there's a multiplication here and then there's an addition. So an algebraic expression is a combination of variables, and it could be one variable, in this case x, or it could be multiple. You could have x, y, z and so on. You have constants, right? And then you have operations, right? And these are the operators that are used. You have plus, minus, division, multiplication. There is no equal to sign. That's something that's very important to note. The moment you put an equal to sign, it becomes an equation, which is different from an algebraic expression. So if you're not familiar with equations, go check out videos where we look at linear equations and so on, and how to solve equations. But expressions do not have an equal to sign. It's just operations, right? So let's just look at a few examples. 4x plus 3. So the variable in this case is just x. The constants are 4 and 3. And the operations, involved, one is a plus sign here, but there's also the multiplication of 4 times x. Look at another case. So you have 5x square plus 3. So the variables, again it's x, because x square is x times x. So the variable is actually x, right? And then you have constants 5 and 3. And then you have the operations. Now you have a 5 times. So there's a times there. X square is x times x. So there's another multiplication there. And then you have the plus. What about this case? So 5x plus 3xy. So there are two variables, x and y. The constants are 5 and 3. And the operations are plus and multiplication. But here again, there are quite a few multiplications, right? There's a 5 times x plus a 3 times x times y, right? There's another one. So 5xy plus 6x plus 9. So again, the variables are x and y. Now the constants are 5, 6 and 9, 3 constants. And again, the operations are plus and multiplication. And can you see the multiple multiplications in this and this term? There's a 6 times x and there's a 5 times x times y. So that's what an algebraic expression is. It's very simple, right? Okay. So now what you see is an algebraic expression. Where do we use it, right? So we're giving an example straight away just so you can understand where an algebraic expression comes in and what's the difference between an expression and an equation. So you have a story here. You have two friends, A and B, right? And they have some marbles with them, right? Now we know that A has 10 more marbles than B. How would you write this as a mathematical expression? So when you see this, somebody asks you, okay, how many marbles does A have and how many marbles does B have? Well, we know that A has 10 more marbles than B. So what do? You say, well, okay, let B have X marbles. So X has now become a variable and we don't know the answer to that, right? So then A has X plus 10 marbles, right? Because A has 10 more marbles than B. And so you have converted this into two algebraic expressions. You have said B has x and the number of marbles with B is x, which is an algebraic expression. The number of marbles with A is x plus 10. Okay. Now how does this become an equation, right? So this is not an equation. I've used the equal to sign here, but I'm just saying B, I'm using B has x marbles and A has x plus 10. Now if I tell you that in total actually we know there are 16 marbles, it's a packet of 16 and we've just opened it and given it to A and B. Now how many do A and B have? So now you can convert this into an equation using the algebraic expressions x and x plus 10, right? Forget this equal to sign here. So we know that a plus b, number of marbles that is equal to 16. That means x, which is the number of marbles b has, plus x plus 10, which is the number of marbles a has, is equal to 16. Now that is an equation because you have the variables here, the two algebraic expressions, right, containing the variables. You have an equal to sign and you have another constant. Now this is an equation and you can solve this equation for x, and check out solving linear equations in one variable, a video on that, that we've posted, which will tell you exactly how this is done. But in this case you just add them. So you do 2x, right? 2x is equal to 16 minus 10, which means x is 3, right? X plus x is 2x. You take the 10 to the other side and you have 16. So how you take it to the other side is to subtract 10 from both sides. So you get 16 minus 10, which means 2x is equal to 6. X is equal to 6 by 2, which is 3. Which means we know b, which is what x is in this case, is 3. So a now has x plus 10, which means 13. So you've seen how you have algebraic expressions that you use to denote different situations or terms, and then you can combine those expressions with an equal to sign in different ways to get an equation. Okay, so hopefully that's helpful. That's explained to you what an expression is and how you form an expression, and then how you use it and how that expression then becomes an equation. But in this video now we're going to focus on expressions. So the next thing you need to understand is what are the terms in an algebraic expression. So I've given you this expression x plus 10, right? So what you see here is there are two terms. There's term 1, which is x, and term 2, which is 10. Now how have we decided that these are the two terms? The answer is simple. When things are separated by a plus or a minus sign, they are called terms. So this small mini expression here, or group of variables or group of numbers, could have other terms. It could be xy, it could be 10xy, and so on. But whenever things are separated by a plus sign, then those are called terms. So in this case, x plus 10, so x is one term, 10 is another term. So let's look at a few examples, right? So x plus 10 we've already done. The terms are x and 10. What about this? So x square plus 2x plus 3. So x square is x times x, but it's a multiplication. So actually x square is one term, plus you take the plus, so that separated by that, so now 2x. So it's 2 times x plus 2x, so that's another term, and then 3. So the terms are x square, 2x, and 3. There are 3 terms. What about this one? 5xy plus 6x plus 9. So separated by the plus sign. So 5xy is one term, 6x is one term, and 9 is another. Now you could have had a minus here as well. It could have been 5xy minus 6x plus 9. Wouldn't have mattered. 5xy is one term. Minus 6x would have been the second, and 9 would have been the third term. So in this case, it's 5xy, 6x, and 9. Simple, right? So terms, basically, you take the equation and, whatever is separated by a plus or a minus sign, those are the terms in the expression. So now let's look at what we mean by factors and coefficients of the terms. So you already know what the terms are, right? So in this case, x square minus 3xy plus 10. What are the terms? X square is one term, minus 3xy is another term, and 10 is a third term. Now if you have a minus, you do include the negative sign in the term. So x square minus 3xy and 10. Now you take x square. Now what you want to do is, each term is made up of a combination of factors, right? What is a factor? So if you remember, again, LCM, HCF, these concepts, basic, so you have HCF, which is highest common factors. What is a factor in that context? So if you say the number 4, find the factors of the number 4. What are the factors? Well, any two or multiple numbers when multiplied together that give you that number are called factors, right? So for example, the number 4 can be obtained as 4 times 1, so 1 and 4 are factors, and 2 times 2, so 2 is a factor, right? Simple. If you want the number 10, right? So 10 can be obtained as 10 times 1, so 10 and 1 are factors, but then actually the factors are 5 and 2. 2 times 5 is a factor, right? Okay. So you look at the term x square. X square is basically the variable x multiplied 2 times. So the factors of x square are x square itself can be a factor because x square times 1, and then x is a factor because x times x is x square. So that's how you get the factors. So this is a concept you should already be familiar with normal numbers, and with a term you basically then find out the different variables and the different combinations of those variables, and those are the factors. Now what is a numerical coefficient, or what is the coefficient of each term? So the answer to that is simple and it's very important. You take this term here. Generally in algebra the variables are written together, so x square, 3x, xy and so on, and the number is in front of it, and that number is the coefficient. So in this case x square, right, that's what we're looking at, it's multiplied, the number here is 1, right, x square is basically 1 times x square, so the coefficient is 1. What about the second term, minus 3xy? So the factors are simple. You have x, you have y, you have xy, you have minus 3, you have minus 3xy and 1, because all these are factors of this term, right? Minus 3xy times 1 is minus 3xy. Minus 3 times xy is minus 3xy, right? And x and y. You can also have, say, 3, for example, but let's not go there. Let's just keep it simple. Okay. So now, what is the coefficient, right? So the combination of variables is xy. The number in front of it is minus 3, so the numerical coefficient is minus 3. And the third term, now this is an interesting one, it's a constant, so there is no variable, right? But that also is a unique term in itself, the constant term. So the constant term is 10. The factors, it's just a number, so 10 and 1. Now we could also go down and say 5 and 2 and so on, but I'm just keeping it simple. I'm just going with the terms showing up here, right? So don't think of it as a mathematical factorization of the numbers. It's just in terms of what shows up here. There's no variable, so I'm just saying 10 and 1. And the coefficient is 10. Okay, makes sense? So you've understood what a factor and a coefficient is. A factor is which terms multiplied give you this term, but the coefficient is the number in front of the variables. Okay, so now what's interesting is using these coefficients, right, and the collection of variables, we try and understand what a like and an unlike term is. So let's look at this expression. You have x square plus xy minus 3. You have a second expression, 4x square plus 2x minus 3xy plus 2y plus 10. Now each of these has a different each term has a different combination of variables. Now if you have the term having the same combination of variables, generally you combine them together, add up the coefficients and you get that term. So each of these has a unique combination of variables. In this case there's x square, that's xy, and there's 3, which is a constant term. In this case you have 4x square, 2x, so x is the variable term. Here x square was the variable term. You have 3xy minus 3xy, so xy is the variable combination. You have y because 2y, and then you have the constant term. So logically, what do you mean by like terms? Simple, right? Terms that have the same variable combination are like terms. So x square and 4x square are like terms. xy and minus 3xy are like terms. Because you take the coefficient out, the coefficient might be different, but the variable combination is the same, right? Now yx is also the same as xy, so the variables can be ordered differently, but xy minus 3xy. And then the constant terms, right, are like terms. Minus 3 and 10, they're both constant terms, so they are like terms. Unlike terms is when the combination of variables is different. So 2x and minus 3xy are unlike terms, right? Because one is x and the other is xy. X square and 2x are unlike terms because one is x square, so the variable combination is x square. In here it's x. So that's what we mean by like and unlike terms. Now how do you quickly kind of understand or find like and unlike terms? And this is important because it is exceptionally critical when you start adding these algebraic expressions together, which we'll do in a different video. So what you do is you list out the terms, right? So what are the based on variable products or variable combinations? You have x square, you have xy, you have x, you have y, and you have a constant in this case, right? You have x square, xy, x, y, and the constant term. You can also do it in the form of a table. So I've just put x square, xy, x, y, and constant, and this will also help you identify the coefficients. You have x square here, the coefficient is 1, xy, so it's 1, minus 3, the constant is 3. And so this table very quickly gives you the expression, right? Because it's x square plus xy minus 3. So it's a very nice way to break down an algebraic expression. So you look at this one. So x square coefficient is 4, xy coefficient is minus 3, x coefficient is 2, y is 2, and the constant term is 10. Now you've broken this expression down into the coefficient and the combination of variables. Now the like terms are the terms with the same variable combination. So x square, because it's with the one coefficient, and 4x square, they are like terms, right? Right. Similarly, xy and minus 3xy, right? Because they show up under the same combination, like terms. Look at the constant, right? Minus 3 and 10, like terms. In this case, x shows up only in one of them, so it does not have a like term in the other expression. Similarly, y is only 2, right? It's 2y. There's no term here with y, so there's no like term in the first expression, right? So x square here and minus 3xy are not like terms, right? Because the variable combination is different. Similarly, minus 3 is a constant term, minus 3xy is an xy term. So, unlike terms. So, that's what you mean by like and unlike terms. It's important to understand this because when you start adding up algebraic expressions, right, and we'll do that in a separate video, you basically add up the like terms, right, together. And that's how you combine expressions together. So, keep this in mind. Now, algebraic expressions, depending on the number of terms, right, with unique variable combinations that exist in that expression can be classified, right, your names. So the first is a monomial. So mono means one. So a monomial means it has one term. So if it's just minus 5x, it's a monomial. 3y, it's a monomial. Right? So it's got one term. Binomial, bi means two. So binomial, you've already guessed, I'm pretty sure, two terms, right? X plus 10. So two terms, binomial. What's the next one? Three terms. So tri, right? So trinomial. So 6x plus 7 plus 9x square. Now remember that when I say a term, it needs to be unique in its variable combination, right? So if you say 6x square plus 7 plus 9x square, no, it's not a trinomial actually. You can call it a trinomial if you really want to, but it's not, because 6x square and 9x square actually are combined together and it will become a binomial. In this case, the variable combination is unique. This is an x term, this is a constant term, this is an x square term. So it's got three terms. So it's a trinomial. So what happens if it's got, in general, what would you call something like this? You would call it a polynomial, right? Poly means many, polynomial. So x square plus xy plus x plus y square plus 10 is a polynomial. It's got 5 terms, right? Now, minus 5x can also be called a polynomial, right? But we know we have a specific term for it, so we'll call it a monomial. So in a polynomial, there could be n terms where n could go from 1 to infinity. Right? Okay. Now, one interesting thing, and this is what I was explaining, you look at this term, right? So x square plus xy plus 3xy plus x plus y square plus 10 minus 3x. So 7 terms, right? 1, 2, 3, 4, 5, 6, 7. So, but does it really have 7 terms? That's something to keep in mind. So you realize when you start combining or bringing together variables with the same variable combination, you say xy and 3xy are actually one combination. Similarly, x and minus 3x are one combination. And so you can actually add up the coefficients, which is how you add up terms. And we have a completely different video on adding algebraic expressions, so that we'll give you a lot of examples in that one. But what you do is you group terms with the same variable combinations together and you add up their coefficients. So actually this becomes x square plus 4xy, because xy plus 3xy, 3 plus 1 is 4, so 4xy, minus 2x, because x minus 3x is minus 2x, plus y square plus 10. So actually this only has 5 terms. This is something to keep in mind, right? It will make things much easier for you. So we've covered a lot of different, aspects, of algebraic expressions. We've given you a lot of examples in each case, right, of what an expression is, an algebraic expression is, kind of an example of where you see algebraic expressions, what the terms of an algebraic expressions are, what are the factors of the terms, what is the coefficient, what are like and unlike terms, and so on. Now what you can do is go to teachyaar.com and take a free quick test, right? And I've dropped a screenshot of the test here. So you can take the test by going to this QR code, scanning this on your mobile device, or we're dropping this link in the comment section and the description section. So you can go there and click on the link and take the free test. and it will give you some more practice on these topics, right? So hopefully that helps you understand these topics a little more. And please subscribe to the TeachYaar YouTube channel so you can get notified as we add more and more concepts and more topics. Please give us a like if you like this video, and feel free to share this with anybody you think will find this useful.